All right, so we'll be going through section 1.2 in the book here on graphs of functions. So x and y intercepts, on this graph right here, we have a cubic function, probably, most likely, because it has two turns on it. And so you can kind of tell that that means it's probably an x to the third. So anyway, x-intercepts, hopefully you remember from Algebra 2 that you got x-intercepts. You got three of them right there. So negative 2, 0, and 1, 0, and 3, 0. All right, so remember those can always be turned into factors a lot of times. So this graph isn't too particular, but we're just doing things in a general sense here. And so you can have more than one x-intercept, but remember for y-intercepts on any particular graph, any graph of a function, you can only have one y-intercept. So that one is 0, 3. All right, so I also want you to remember or get used to some terminology, maximums and minimums. So we have what are called relative and absolute max and mins. So a relative max or min would be like this piece right here. So negative 1 looks like 4. So a relative maximum on this graph at negative 1, 4. It's called a relative maximum because it is the highest place on the graph relative to anything else around it. So it's like a mountaintop. It's not the highest on the whole graph because the graph does keep going up and up forever, but relative to the places around it, it is a maximum. And then you have a relative min over here. It looks like probably 2, negative 2. So relative minimum at 2, negative 2. Now, it is not an absolute minimum because it's not the lowest value on the whole graph, but we'll get to some of those details later, but just to hear those words. All right, the next page here. You also have to be able to find x and y intercepts when you are given an equation of the function. All right, so finding them on a graph is easy, but when you have an equation, that's a little bit of a different story. But remember, an x and a y intercept, just like you saw on the last page, if you have an x intercept, that means that the y value is equal to 0. If you have a y intercept, that means that the x value is equal to 0. All right, so it's very, very simple to, hang on, I feel like I skipped something. Oh, never mind. So it's very, very easy to plug in 0 for x in all these problems and find the y-intercept. All right, so why don't we just do that real quick right now for all of them. So if I want the y-intercept, I would basically just plug in 0 for x and then get the answer. So in this problem, I would get 0 plus 8 over 4, so I'd have 2. In letter B, I plug in 0, so it's kind of like this. This gets wiped out, this gets wiped out, and you got negative 5. So in a polynomial, any constant is going to be your y-intercept. So that would be 0, negative 5. That's my y-intercept. All right, over here, for my square root, I have my y-intercept is going to be at 0, radical 6. All right. And here, let's see my y-intercept for my absolute value function. And you could, of course, graph these things and see it there too, but 0 and negative 2. All right, because you're going to get absolute value of 4 minus 6, so you get negative 2. All right, over here on letter E, this is a polynomial, but notice it has no constant function. So when you plug in 0, it wipes everything out. So your y-intercept is going to be 0, 0, and that's the one y-intercept that is also an x-intercept because it's at the origin. So it's on the y and the x-axis. This last one here. So what you're imagining here, wipe out, wipe out, wipe out. All these things with x's are gone. So your y-intercept, it's going to be left with 5 over 10, so 1/2. So 0 and 1/2. So again, y-intercept, very easy to find. Just plug in 0 for all the x's. But now the x-intercept. So the x-intercept is a little bit more challenging. The x-intercept is when y is equal to 0. So, in a lot of problems, that's not that difficult. So like in this problem right here, if I let y be 0, I would have 2x to the third plus 8 left over 4. I would just solve this equation. So if I multiply by 4, it's still 0. Then I subtract 8. So I have 2x to the third equals negative 8. I'm going to go ahead and divide by 2. So I have x to the third equals negative 4. And so remember, it's okay for a cube root to be negative, or for a cube to be negative. We can still get the answer. And so my answer is going to be, my x-intercept is the cube root of negative 4. So with a cube root, you can pull the negative out front. So you can say it is negative cube root of 4. And so I would write that as a coordinate. Maybe you have more space than me, but my x-intercept would be negative cube root of 4, comma 0. I'm going to go back to the blue pen because it's a little skinnier. All right, so over here for letter B, remember I'm trying to pretend y is 0. So basically I'm putting a 0 here. So then I have 2x squared plus 9x minus 5 equals 0. So this is a factoring situation where we'd be practicing that. All right, so I factor it. So 2x and x. If I put a 5 here and a 1 there, I'm getting 10 and 1 on the outside and inside. So I want my 10 to be positive and my 1 to be negative. So I can tell that the solutions to this are 1/2 and negative 5. So this is a parabola, so I probably have 2x intercepts at 1/2, 0, and also at negative 5, 0. So hopefully some of this is coming back to you. All right, so for letter C, I want the answer to be 0, so I just have to solve it. When is 0 equal to the square root of x squared plus 6? So I square both sides. So I get 0 equals x squared plus 6. This is kind of a trick question. Ask yourself, when is x squared plus 6 going to be 0? So it's not going to be 0 because x squared, even if you plug in 0, you're still going to have the plus 6. So you're never going to get 0. X squared will never be negative, so it can't negate the 6, and so you can't get 0. So if you went further and took away 6 from both sides, you get x squared equals negative 6, which we know could never be true. A square cannot be negative, so that's no solution. So there are no x-intercepts for this problem. And if you graph it, you should see this not crossing the x-axis. All right, so for letter D, remember I'm letting this be 0. So I got 0 equals x plus 4 minus 6, absolute value. So move the 6 over. So 6 equals absolute value of x plus 4. Or, you could graph this thing. This is moved to the left 4 and down 6, this absolute value function, this V shape. But let's just do it from here. So I got x plus 4 equals 6, or x plus 4 equals negative 6. So one of my x-intercepts is 2. The other one is negative 10. And of course, you could write them as points as well. All right, so over here with letter E. So I already found one of the y-intercepts was 0, 0, and that's also an x-intercept. So if I set this thing equal to 0, don't forget your good old factoring. You can pull an x out of all these things. So you got x, 3x squared minus 10x plus 8. And then try to factor, or you could use a quadratic formula if needed, but I think I made it so it will factor. And actually, you know what? I remember there is a mistake here. So this plus 8x in this problem right here, this is supposed to be a negative, because when I was working it out, it did not factor right. I made a mistake. So it's being negative. All right, so I got a 3x and an x. Let's try a good old 4 and 2. If I put 4 here and 2 there, I would be getting 12 and 2. And 12 and 2 can make 10. I want the 12 to be negative and the 2 to be positive. All right, so I'm getting 3 x-intercepts. I'm getting 0, negative 2/3, and 4. And again, you could write them as points if you needed to. We already knew about the 0 one. All right, last couple pages here. All right, so then you have symmetry to talk about. So graphs can be symmetrical. We're going to talk about 3 different ways. I mean, I guess there could be more types of symmetry, but these are the only ones we really care about. This one right here, I kind of crossed off. The top one, I kind of crossed off the name area. It doesn't have a really special name. We just call it like x-axis symmetry. So I decided later that I wanted to call it x-axis, so you don't really need to cross it off. But it's not a special one like we use for other things. All right, so you can see here that, when you look above and below the x-axis, you get basically a mirror image of itself. So if you took your paper and you folded it over the x-axis, your graph would be the same on either side. Okay, so the test here is that every x value has opposite y values associated with it. So what's going to happen is like basically you're going to get a lot of times you get like a y squared here. So when you plug in an x, the y is plus or minus that, and so you'll see in some problems that we do later that that's usually what happens. When you start to see y squared in a problem, it's like a sideways problem like this. All right, so an algebraic test for this. So what you'd want to do is in your equation, if you can replace y with negative y, and you get the exact same equation, you get an equivalent equation, then you know you have x-axis symmetry. So replace y with negative y and arrive at the same equation. All right, so you'll see in some of the problems what we're talking about. All right, the next one. So this next one here, you see that if you kind of fold your paper over the y-axis, it's like y-axis symmetry, but we have a special name for that one. That's called an even function. It's an even function, okay? And the graph test for it, so basically what happens is that every x value and its opposite have the same y value. So if you go over here to, like, let's say, I don't know, 2, you're going to get to 4. If you go to negative 2, you also get 4. So every x value and also the opposite x value have the same exact answer. Okay. So every x value and its opposite have the same y value. So in this case, if you replace x with negative x in the equation, you get the same exact answer. Okay. So these two down here, this one and this one, these are the ones that we really look for and you need to know really well. The x-axis one above, I mean, that's something to notice, but you don't really use that later on much. All right, so this next one, the name of it is to be an odd function. So when you have an odd function, it's kind of hard to show you on the video, but imagine this part right here twisting 180 degrees. So if you twist that around to there, like you twist it 180 degrees, kind of like in geometry, then it basically produces the same exact picture down here. So it's more like a rotational symmetry. So what you say is that your graph is symmetric with respect to the origin. So if you twist the right side 180 degrees, it's basically going to copy or lay on top of the left side. Okay, so that one, the algebraic test is this. Every time you plug in a number and get an answer, so if you plug in a number and get an answer, if you plug in the opposite number, you get the opposite answer. So that's it. All right. So if you replace x with negative x, you arrive at the exact opposite expression. So you arrive at, or you get the exact opposite expression. So you'll see what I mean when we do some of the problems. Okay? All right, so on a picture. So this is our last page. Yeah, our last page. So when you have a picture, you're just going to have to look for the symmetry on it. So in this problem, in this letter A, when I look at this right side of my graph, right, you can see that if I take that, let me see if I can do it. If I take it and I twist it around, I need to move it over as I twist it. If I twist it around, you see how it's the exact same problem. So that twisting around the origin, that means that it's an odd function. So this one over here is odd. It also means that because if I inspect it, if I go to a question on the right side, so if I go to 3 pi over 2, the answer is negative 1. Well, if I go to negative 3 pi over 2, the answer is the opposite thing, positive 1. So that also proves it's an odd function. It does that for everything. If I go to, let's say, I don't know, pi over 2, it goes up to 1. If I go to negative pi over 2, it goes down to negative 1. So if I plug in the opposite thing, I get an opposite answer. That's an odd function. And by the way, this is a graph of the sine function, which we'll be doing later in chapter 4 and 5. All right, letter B. So letter B, if you think back to one of your pictures here, it hopefully to you looks kind of like this guy right here. It's symmetrical over the y-axis. So the y-axis kind of divides this graph. If you go to one side, you get one answer. If you go to the exact other side, you get the same answer. So this is an even function. All right, now letter C is a trick. Letter C has nothing. If I look at the y-axis, the graph is not the same on either side of that. If I look at the x-axis, the graph doesn't match on either side of that. If I try to look at the origin, if I twist the graph on the right over, it doesn't produce this little piece on the left. So nothing's happening with this. If I try some problems, like if I try to plug in, let's say I plug in 2. If I go to 2, the answer is 1. If I go to negative 2, the answer is not negative 1. It's like somewhere like way down here. So nothing's going on with this graph. It's neither or none of these things. So this has no symmetry. I mean, it does have symmetry along the axis of symmetry, but we're not talking about that. Okay, we're only talking about those 3 types. Okay, so if you're given an equation in this last little part here, if you're given an equation, of course you can always graph it. And so, if I cheat a little bit, this is an upside down parabola, an up 6. So I know a parabola upside down moved up 6. That reminds me, hopefully, of this one right here. This is an even function, okay? But I want to show you without the graph, like how you would do that, because you won't always be able to make a nice, pretty picture and stuff like that. So what you want to do is you basically, unless you see y squared, because that's kind of something a little bit different, plug in negative x. So let me do this. F of x, which is y, equals negative x squared plus 6. So that's the same exact problem that I already have. Like I just rewrote it with f of x. So let's do this. F of negative x. If you put a negative x in place of all the x's, so we get negative, and in place of this x, I put a negative x squared plus 6. What does that do? So this right here, this part right here, just makes x squared, and I still got the negative outside, so that's negative x squared, and then plus 6. So do you see that when I plugged in negative x, it didn't matter? Because what happened was the square got rid of my negative, and it just went back to exactly what it was to begin with. So it doesn't matter if you have a negative or a positive, you just get the same exact answer. So that is like this right here. Positive answer, negative question, the same thing, same answer. This must be an even function. All right, so let's try letter D. So we're already given f of x, let's do f of negative x. So if I put negative x in place of all this stuff, I get negative x to the third minus 2 and then negative x. So when I do that, I cube it out, I get negative x to the third plus 2x. So do you notice that this is the exact opposite of the original question? X to the third became negative x to the third. Minus 2x became plus 2x. Everything in my answer was the exact opposite of the question. So this must be an odd function. All right, so let's try letter E. So I'm going to rewrite this as f of x just to follow my rule. So 4x squared plus 3x minus 1. So f of negative x equals 4 negative x squared plus 3 with a negative x and then minus 1. So when I work that out, I get 4x squared because the negative goes away, minus 3x and minus 1. All right, so I have an issue here because look what happened. 4x squared stayed the same. So I'm thinking, I'm going to get an even function. But then look what happened. 3x became negative 3x, and then the -1 stayed the same. So some of it stayed the same and some of it like switched to the opposite. So it followed both rules. So that means it's a good old nothing. This has no symmetry. Or it's not symmetrical in any of these three ways. All right, and this last one right here, x minus y squared equals 5. So in this problem, what you would want to do is y is being squared. So you want to replace the y with a negative y. So if I replace this y with a negative y, what would happen? I would have x minus this negative would go away, y squared equals 5. So what's happening to me here is when I replace a y with a negative y, I got the exact same thing. And so this is basically just x-axis symmetry. And if you wanted to, you could solve this for y and graph it. What you would get is a sideways parabola. And so we talk about these more later, but this is x-axis symmetry. You don't really have to know those as well as you have to know even and odd functions. So in summary, these are the rules to remember. When somebody asks you if a function is even, what has to happen is you plug in x and you plug in negative x, but you get the exact same thing. So putting an x and a negative x produces the same exact answer. This means that you are symmetrical over the y-axis. So, you get to remember like a good old parabola is symmetrical over the y-axis. All right, and an odd function, the rule here that we're going to say is f of x is equal to negative f of negative x. So when you plug in a negative, you get a negative of the original. Oh, no, hang on, I wrote that. Oh, hang on, wait a minute, erase that. Write this, f of negative x equals negative f of x. Sorry. So when you plug in negative x, you get the opposite of the original. Okay, there we go. All right, so the symmetrical odd function symmetry about the origin. So a good one to think of for that is like a nice little cubic function, symmetrical about the origin. So if you take the right side and twist it about the origin, you get the same thing. All right, I'll see you in class. And remember, your homework was to finish 1.1 and then copy down these notes for 1.2. I'll see ya. Bye-bye.